Hello everyone, good morning. Welcome to the live lecture of Doubtnet. So we were on our chapter which is haloalkanes and haloarenes. We have already completed the preparation methods of haloalkanes. We've already studied the physical properties of haloalkanes and today we are gonna do the preparation methods of haloarenes. What are haloarenes? We'll discuss this in detail and then we'll do the preparation methods. There are very less preparation methods in haloarenes but all of them are really important, right? So this is lecture number 8 of haloalkanes and haloarenes. If you have missed any of the lectures till now, please go and watch that lectures. They are available on YouTube app as well as your Doubtnet app, right? Okay, let's start. If you don't know me, let me introduce myself to you. My name is Shagun and I've done my masters in chemistry from Miranda House Delhi University. I've added few qualifications. If you want to give a look to it, you can. Otherwise, we can skip this portion. So what are we going to learn today? We'll do the preparation methods in this methods of preparation of haloarenes. We'll be discussing your Gatterman reaction, Sandmayer reaction, Balz reaction, reaction with Ki, and so on. Also, we'll be practicing NCERT questions as well as previous year questions of boards exam. But before we start, let's hear announcement, small announcement. Announcement is that Doubtnet is launching a new course of class 12th, right? This course will be available on Doubtnet app. Whenever you install Doubtnet app and purchase the course, you get all the recorded classes in it. You get homework after every class. We take your test weekly. We have books available for you. We also have NCERT solutions. We follow proper timetable and we give you the teacher's notes. Also, there is a way that explains you how to use Doubtnet app effectively, right? This course will be taken by our top teachers. They have given the proven best results. There will be doubt clearing sessions. They will be your teachers, physics teachers, chemistry teachers, bio teachers, maths teachers and English teachers. Their lectures are available on Doubtnet app as well as YouTube app. You can go and check out. The proven best result from last year is that 91% in class 12th 91% in class 12th was scored by Harsh Kumar, who was the district topper of Aurangabad, Bihar. Right? 91% in class 12th by Shreya Ishani, district topper, East Champaran, Bihar. And we have more than 100 students who have scored more than 85% marks. Doubtnut is #1 institute in solving your doubts. We give you homework, we give you notes, we give you tests, and all of these have video solutions available. Whichever questions we give you, they have proper video solutions. You can check the video solutions. We also have available text solutions for you. You can conveniently check it out. So in this way, most of your doubts are clarified. Also, if you wish to check the classes or if you wish to take the classes, you can take the live classes as well as the recorded classes whenever you get the time. Now, question is, how do we clarify our doubts? You simply have to click a photo of whichever question you are stuck at. You have to find the solution of that particular question on Doubtnet app, or you can comment your doubt in the comment box of the class. Respective teacher will answer your doubts and those answers will be verified, right? We also have text solutions available for you and video solutions too available. If you have any problem, you can call at 0124758250 anytime or comment in the comment section. Now, can you please click on the poll that will be raised right now? You have to tell me whether you are interested in joining this class 12 board course or not. Whatever is your answer, you can answer that. Okay. Now, we have good news for you all. The good news is that Doubtnet is organizing a scholarship test on 18th July. These scholarship tests will be for 6th to 12th students as well as those students who are preparing IIT JEE and NEET competitive exams. In this scholarship test, every participant gets 10% discount. Every participant gets 10% discount and the one who scores well gets 1 crore worth scholarship. Right? You can register now and the result of this test will be announced on 18 July itself at 6 p.m. To register, you'll get the description link. You will get every information in the description link or in the comment section. You can register from there, right? Also, Doubtnet is organizing or launching an English speaking course, and our top teachers are taking this English speaking course. The course has already started from 8th July. If you need any information, again you can check it out in the comment section as well as description box, right? Okay, so we have already completed what all we have completed in haloalkanes and haloarenes. Let me give you a quick recap. We have started with your classification of haloalkanes and haloarenes in lecture number 1. We have completed the classification. Then we started with preparation methods of haloalkanes. After preparation methods, I've taught you in parts. Preparation methods of haloalkanes has been completed. We have already discussed the physical properties of haloalkanes, in which we have discussed melting point, boiling point, density, solubility, and etc. Now we'll be doing preparation methods of haloarenes, and thereafter we'll be discussing the chemical reactions. So let's start with preparation methods of haloarenes, but before that you need to understand what is haloarene. See, haloarene is something. Halo means halogen, arenes means your aromatic system. Usually we consider benzene in arene because benzene, as you know, follows Huckel rule and it is an aromatic system. If benzene has directly halogen group attached to it, that particular organic compound becomes haloarene. If I say, is this a haloarene? Is this a haloarene? My question to you is this a haloarene? The answer would be no, this is not haloarene. Reason being, your halogen atom Cl is not directly attached to benzene. It is attached to CH2 group, and that CH2 group is further attached to benzene. So this is not haloarene. Haloarene is something which is directly attached to benzene. For example, your fluorobenzene, bromobenzene, etc. This is haloarene. In fact, this is also haloarene because you have halogen group Cl now attached directly to benzene group, right? We can say this is also haloarene. I hope you have understood what is haloarene and what is not haloarene. People might get confused, students might get confused by saying that this is haloarene, because we have arene system as well as halogen system, but they are not directly attached to it. They are not haloarenes. They all are haloarenes, right? Okay. Since now we have understood what are haloarenes, we can easily prepare haloarenes. The first preparation method to prepare haloarene is from toluene. Benzene group and a methyl group which is directly attached to the benzene group is commonly known as toluene, and if you give a IUPAC nomenclature to it, this is methyl benzene. The common name of methyl benzene is toluene and the IUPAC name is methyl benzene. Whenever you react methyl benzene or toluene with X2 in presence of iron and dark, addition reaction. This is one of the hydrogen is substituted with X. This is substitution reaction. Substitution reaction occurs in your toluene. I repeat, in toluene add X2 plus iron which acts as a catalyst in dark. The reaction has happened. You get halogen group attached to ortho position of your methyl group as well as para position of your methyl group. You get ortho halotoluene and para halotoluene. I hope you know what are ortho and para positions. If I talk about toluene, if I say this is toluene, what are ortho positions? Ortho positions are, this is the methyl, this carbon has methyl which is directly attached to this carbon. Carbon adjacent to the carbons which are directly attached to the methyl groups are your ortho positions. then we have your meta position, and then we have your para position, right? If I make toluene this way, what will be your ortho position, meta position and para position? This is the carbon which methyl group is directly attached to. Adjacent carbons to the carbons adjacent to the carbon which has methyl group attached to it, they are your ortho carbons. They are your ortho positions. We have next position to the ortho position is meta position. We have two meta positions, and the last position we are left with is the para position. If you write the nomenclature, or if you do the numbering, this is 1, 2, 3, 4. We can say 1, 2 positions are your ortho position, 1, 3 positions are your meta position, and 1, 4 position is your para position. Because you can number it, this has been numbered as clockwise, this is 1, 2. You can either number it anti-clockwise, this will be 1, 2, 3. Again we'll have the same, 1, 2 is ortho position, 1, 3 is meta, and 1, 4 is para position. When we talk about toluene, why is that ortho and para positions have been substituted only? The reason behind this is, in toluene we see hyperconjugation. In hyperconjugation, the CH bond is broken. It is converted into the pi bond, and the pi bond of the benzene is converted into your the electron density increases at ortho position. So the hyperconjugated structure leads to the increase in electron density at ortho position, and we have this. The electron density has been shifted and has been taken away from H, so H positive is developed. This electron density on ortho position will further resonate and increase the electron density at para position as well. So they are your hyperconjugating structures and resonating structures, right? These negative will further undergo resonance and generate electron density again back to your second ortho position. So as we have understood, the electron density is increasing either at ortho position or para position. The electron density comes here, here, or here. It is ortho, ortho and para position which has high electron density. It takes out X positive from it and attaches itself to it, right? So we get ortho halotoluene and para halotoluene as the major product whenever we add toluene, whenever we add X2 or halogen in toluene in presence of iron and dark conditions, right? So this is the way to prepare haloarene. This was the first preparation method, and second and the most important preparation methods are to prepare your haloarene from diazonium salt. These are very important, very important methods to prepare your haloarenes, and diazonium salt is one of the best way to prepare your haloarene, because whenever we prepare haloarene, N2 gas is related and it is thermodynamically favorable process. I'll explain you how, but let's understand how do we prepare haloarenes. We'll also study this in our chapter amines, right? So this is aniline. Whenever a benzene group is attached directly to your NH2 group, this becomes your aniline. Common name is your aniline, right? Whenever aniline is reacted with NaNO2 and HX, here X can be either Cl or Br. Most commonly we observe HCl, or HBr is also observed, but HCl is most commonly observed. NaNO2 and HCl forms HNO2, right? And we also have X minus with it, NaX. NH2 has lone pair, nitrogen has lone pair. It takes the H positive ions from the from HNO2, protonates itself and undergoes certain mechanism to form benzene diazonium halides. We will not discuss mechanism, it is quite large and it is not useful in class 12 boards, so we won't discuss the mechanism of formation of benzene diazonium, but we'll learn that aniline when reacted with NaNO2 in presence of HX at 273 Kelvin and 278 Kelvin, we get benzene diazonium halide. This is benzene. Di means 2 Azo means nitrogen. Em stands for the positive charge and halide is X minus. I hope you can now remember the structure of benzene diazonium chloride or halide. The name might look difficult, but if you break down the name, you'll be easily able to remember what is benzene diazonium chloride. This is benzene. Benzene diazonium, di means 2, azo means nitrogen, Em means positive, X minus. This is benzene diazonium chloride. Once this is prepared, this is further reacted with certain chemicals that leads to the formation of your every and each halides, haloarenes. You can prepare iodobenzene, bromobenzene, chlorobenzene. In fact, fluorobenzene or cyanobenzene are to prepare from benzene diazonium halides, and this is really important, right? So once the benzene diazonium halide, in case of this, we have taken Cl, because in HX we have taken HCl. X minus would be Cl minus, so this becomes benzene diazonium chloride. When you react it with copper, which is in the powdered state, copper in the powdered state plus HCl, it leads to, it is the source of Cl minus. Cl minus attacks here, removes N2 and N2 gas is removed and we get chlorobenzene. This is the Cl directly attached to the benzene. This is haloarene. This is chloroarene, right? N2 is released in the form of a gas and it makes the reaction thermodynamically favorable. It makes the reaction thermodynamically favorable, right? How does this reaction, or how does release of a gas makes the reaction thermodynamically favorable? You must have or you must have gone through the chapter called thermodynamics, and in third law of thermodynamics you must have seen this reaction delta G is equals to delta H minus T delta S, where delta S was entropy, and entropy, whenever the gas is released, entropy increases. This whole part becomes more negative and that leads to more negative delta G, because release of gas increases entropy. Delta S is positive, minus of T delta S becomes more negative as delta S is increasing, and minus impacts delta G, a more negative value, and this leads to more spontaneity in the reaction, because we have already understood that whenever delta G is less than 0 or negative, reaction is spontaneous, right? So this leads to more negative delta G and reaction becomes more spontaneous. So this was the Gatterman reaction. To prepare chlorobenzene, you have to take copper powder and HCl. To prepare bromobenzene, you have to react benzene diazonium chloride with copper powder. And now instead of HCl you have to take HBr, because here Br minus will act as your nucleophile, attack it, remove N2 and form your bromobenzene. You must remember Gatterman reaction is only used for preparation of chlorobenzene and bromobenzenes. Iodobenzene and fluorobenzene cannot be easily prepared by this reaction, right? Also, we have another method to prepare chlorobenzene and bromobenzene. The next is your Sandmayer reaction. This is your Sandmayer reaction. Same thing, you have to react benzene diazonium chloride with Cu2X2, right? This is copper CuX. If you consider this as CuX, X can be your Cl and Br, and hence this can lead to preparation of chlorobenzene and bromobenzene only. Nitrogen gas is always released in benzene diazonium chloride, and this is your Sandmayer reaction. Now, how would you learn whether or which of the reagents are your Sandmayer reagents or your Gatterman reagent? I've already learned it with the trick, and I'll give you the trick to learn the reagents. If you remember Gatterman reaction, we have used copper powder in presence of your HX, where X were your Cl and Br, whereas in Sandmayer reaction we treat benzene diazonium chloride with Cu 2x2. If we take 2 common out, this is CuX only, where X again is Cl and Br, right? Now you must remember that whenever we have sand, sand is just like powder. We do not have to use powder in the reagent. In Sandmayer, we do not use copper powder, whereas in Gatterman, we do not have sand. Sand means powder. We do not have powder. We have to use copper powder. This is the way you can learn it. Just do the cross way. If we have sand, we do not have to use powder. This is copper X. If we do not have sand in Gatterman reaction, there is no sand, we have to use copper powder. So this is the way you can learn the reagents. And now how to prepare iodobenzene and fluorobenzene. The simple reaction is react benzene diazonium chloride with Ki. Here I minus will attack here, remove N2 and form iodobenzene, right? Also we have Balz-Schlemann reaction for preparation of fluorobenzene. The only thing you have to do is you have to react aniline with HNO2, that is NaNO2 plus HbF4. Instead of HX, now you have to use NaNO2 plus HbF4. NaNO2 plus HbF4 forms HNO2. You can take HNO2 directly, or you can take NaNO2 plus HbF4. So this again would lead to formation of benzene diazonium. Now it is not halide, it is your side anion is BF4 minus. So instead of X minus, because you have not reacted HNO2 with HX, we have reacted HNO2 with HbF4. So the anion is BF4 minus. So the name becomes benzene diazonium tetrafluoroborate. Once benzene diazonium tetrafluoroborate is formed, you heat that, and heating leads to formation of fluorobenzene, nitrogen and BF3 is removed, because BF4 minus is a source of F minus. F minus attacks here, remove N2, N2 is released, BF4 minus has been converted into BF3 because F minus has attacked to benzene, leads to the formation of fluorobenzene. So this is the way you prepare all your halogen atoms, haloarenes. Your chlorobenzene, your bromobenzene were prepared by using your Sandmayer and Gatterman reaction. Your iodobenzene was prepared by using your Ki, and Balz-Schlemann reaction is used to prepare your fluorobenzene. Also, we have learned that your toluene when reacted with X2 in presence of iron and dark leads to formation of ortho and para products. Ortho and para products, right? Also, you must remember that whenever you react X2 in presence of sunlight or HNu, it is written, you must understand this reaction undergoes free radical reaction. In this reaction undergoes free radical reaction. What you have to do is you have to form a free radical, and the most stable free radical from the substrate is CH2 radical, because once the CH2 radical is formed, it will undergo resonance in this manner. This will again undergo resonance and so on. So the radical is delocalized, and delocalized leads to the stabilization. Most stable free radical is this CH2 radical. Then it reacts with X radical to give you benzylic haloarene. This is not haloarene, benzylic halide, right? So this is the thing you have to remember whenever you react X2 in presence of iron and dark conditions, you get haloarenes, and whenever you react X2 in presence of a free radical, you get benzyl halide. Okay, so we are already completed. Now it's time for your quiz. The quiz, you have to tell me that whatever we have learned till now, the quiz questions depends upon that, and you have to give the right answer to the quiz. The first question of the quiz is this. If you aren't able to see, I'll move a bit. So the reaction involving the treatment of benzene diazonium chloride with copper powder and HCl is treated as. Which is the reaction? Whenever you treat benzene diazonium chloride with copper powder and HCl, you have to tell me the name of the reaction. Okay, let's move to next question. Which of the following is not an example of Sandmayer reaction? You have to tell me which of the following is not an example of Sandmayer reaction. Okay. So the reaction involves treatment of benzene diazonium chloride with copper powder and HCl is known as. I already gave you a trick. Whenever we treat benzene diazonium chloride with copper powder and HCl, in copper powder is already involved. We do not have to use sand. This cannot be sand. This is Gatterman reaction. This is Gatterman reaction. Correct answer is answer B, right? This is your Gatterman reaction. Because we have copper powder and we do not use copper powder in Sandmayer. We use your copper powder in Gatterman. So this is your Gatterman reaction. Correct option is option B. And in the next question, which of the following is not an example of Sandmayer reaction? We have to understand that we in Sandmayer reaction we used to take copper X in presence of your CuX, or we used to take Cu2X2, right? So if we see this is CuCl, this is Sandmayer, this is CuBr, this is also Sandmayer, CuCN is also a Sandmayer, but C6H5N2 positive in presence N2Cl in presence of KIN warm, this is not a Sandmayer reaction. Correct option is option D for it, right? So this was it we have done. In next class we'll be discussing the chemical reactions of your haloalkanes, and we'll also be doing some previous year back exercise questions. And once we complete this chapter, we'll do the back exercise in the sequence manner so that it does not create any problem to you. Every chapter is completed 100%, and we'll do that on at 10:30 p.m. Uh, 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 at 10:30 p.m. on Friday, and we'll be doing with chemical reaction. Make sure that you revise whatever we have done till now. Till then, thank you so much for watching and have a nice day.